Okay, this is all fair use. No money is made by Mud Fossil University or me about this. And if you look into this, it's for the purposes of criticism, comment, news reporting, teaching, scholarship, education, and research. And then there is something else that makes it very important, is that it's transformative. I am doing something that is transforming the way we think. If what I'm saying is correct and it needs to be scrutinized, it transforms everything about the way we are thinking. So I claim fair use. Huge day for Mud Fossil University. This is Roger once again. NASA OSIRIS-REx mission discovers water in clay deposits on asteroid. Now I'm going to show you this asteroid. They went up and they want to find out what this thing made out of, what does it look like. So they sent up a rover out there, and it is circling the thing right now. And I can tell you what it's already made of, and I can tell you actually what it is. So let's take a look at it. Okay, this is the article about finding water on Bennu and also finding these hydroxyl groups, and which means it's from life. And they can say anything they want, but once you get into hydroxyl groups and the clay, which they found, and these organic molecules, extreme complex carbons, that is life. And I have other evidence to prove what I'm talking about. And this particular bump right there is another thing that I can explain, and that is something that they are desperately trying to figure out. See that bump as it comes around? See, this thing's basically round with that bump on it. So what's that all about? You know, they say, well, what about this water? Data comes from 2 spectrometers, visible infrared spectrums. They're looking at these things, and then they find in hydroxyl groups revealed presence of hydrated minerals. That's water in different minerals, and they have hydroxyl groups, and that is what life works on. Enzymes. They exist globally across the asteroid, water-bearing clay minerals. I've been saying this for years. These clay minerals are not just clay laying around for no reason. Those are from the flesh of creatures. Clay is the red-blooded flesh of creatures. Sometimes it's a different colors, depends on what kind of creature it was. But clay is creatures' flesh. Now, this means that Bennu's rocky material once interacted with water. Yeah, because it was alive. Bennu itself is too small to have ever hosted liquid water. It was inside of a body. So I'm going to show you the evidence to prove what I'm saying, and that is not the only one. Not the only one by any means. Now, on this mission, they claim they found hydroxyl groups and don't really talk too much more about that, but look at what a hydroxyl group is. Before we get into specifics of hydroxyl groups, it's important to get a better understanding of carbon-based molecules. That's life. They can say anything they want, it just contains carbon. That's right, because it's life. Organic chemistry, organs. Organic chemistry is the study of carbon-based molecules. That's what life is. It's carbon-based molecules. These molecules, otherwise known as organic molecules, are so important, life could not exist without them. DNA, proteins, carboxylates, carbohydrates are examples of organic molecules that are necessary for every living being. And the hydroxyl group is one of their essential building blocks. How can they not get this into their head? The chemistry is there, the biology is there, the anatomy is there. Even the ancient texts talk about these things being from life, and they are. I'm sorry, they are. So is the Earth, and we're killing it. We're literally killing the Earth. Mars is dead, and I have videos on all of this. I've explained all of the chemistry all of the anatomy on Mars. Very, very simple. Very simple. All right, this is Bennu. You see that? That is biological. Wait till you see this. Now, there's like almost a stalk with a cone sticking off. You see it? It's sticking down, and then it flares out right there, and then that bump right there. That's the abrupt transition of this tendon antithesis strap. That is where it broke off. And that is why, you see how perfect that is? That, like, if that was anchored in the ground or in another piece of stone underneath, you would not be able to move this, because inside those straps there's about 1,000,000 little tiny fibers, and they are strong as can be. And these are what anchor, like Krishna's butterball, a big rock sticking up like this off the earth over in India somewhere, and they decided they're going to try to push it over because it looks so scary. They had 7 elephants up there, they couldn't move it. So these things are locked in with these kind of emplacements, the same as they are in your body. And boy, I'll tell you, the tendons in your body are tough, and these are tough. So that's what the stalk you see sticking up here. This one just broke off at that place. They can't understand how this could be like it is. Well, it's because it was an tendon enthesis. All right, tendon balls are made out of calcium carbonate, CaCO3, with mineral inclusions in them, and there is some other material inside of them. I don't really fully understand what the chemistry is, because there's so much of them around, and I really don't have the ability to go deep into that chemistry. But these are the balls that we're finding all over the earth, thousands, everywhere, and they're gigantic. Now, they have a little tag to them. You see this? That holds them in position. And those little tags will break off in certain ways. Sometimes they'll break off inside, sometimes they'll break off on the outside and have a little neck sticking out. And the one that we saw has a neck sticking out. I'm going to show you others that have necks sticking in. It depends on what type of tendon ball they are. Some of them are ligaments, some of them are tendons, some of them are strap muscles down and so forth. And some of them now they have discovered are interstitium, which is the just below the skin level, that all these little tiny balls are on straps, and that's what makes your skin flexible and return. And that is in clay. Same thing they're talking about clay on this thing. Clay is the eroded, well, it's decayed flesh. It's decayed flesh. It's loaded with ferrous oxides because of its red blood and all the other minerals that are in the flesh of the body. And I'm going to show you the spectral analysis. Well, let me show you what I got. Now, this is a spectral analysis. This is what they're going to find up there. They're going to find some of all of this stuff, because it is sand is the eroded part. Sandstone is eroded, and that's the silicon erodes primarily from skin. Then you get into the mudstone, is the fleshy red clay. The skin is mostly silicon, and that is, see the silicon red over here? All the red is here. Once you get rid of your skin, then there's not much silicon left. But that's where silicon and sand comes from, is skin. That's where the sand comes from. Then you have your mud as your fleshy stuff, and then you get into your lime, and you get down into the calcium and the magnesium and all the different aluminum and so forth. This is not mine. Again, I'm a fair user. Somebody put this up, and I don't know who it was, so I can't credit whoever it was. But this is the spectral analysis and the chemistry, because each one of these little bumps indicates a different type of element, and some of it's dense and some of it's not dense. And what does that mean? It means it eroded away in the sand, so it's gone from the mudstone and the limestone, a little bit left. But then you go into your other things, and they're not so dense up here, and they're denser down here. You see? Calcium, that's when your bones in here, your calcium was down here. You don't have a whole lot of calcium in your skin, the sandstone. So these are things they have to look at. It's very, very obvious once they can open their eyes and see with mud fossil eyes. You have to understand mud fossils. All right, this is how your body breaks down. The mud and the mudstone is the clay. That's when it's all mud and mudstone and the slippery, slimy red clays. That's your flesh. And then as you go up towards the limestone, which is the tendon, that's the structural part of your body. This is the part that erodes and runs away. That's why you only find, literally almost always, limestone is left. Now, the bones that they find of the dinosaurs and so forth, those are creatures that were not the same as mud fossils. Mud fossils were preserved in the Great Flood. Salt water erodes and dissolves the calcium type minerals inside of bones, but it preserves the flesh. That's why we find mud fossils, and where the bones were, they've transitioned into what they call source rock in the petroleum industry. So as you go from the clay of your skin up inside, and it gets stronger and stronger, and then you have the connective tissues and the marl and the marlstone, and then it gets calcaneus, and you get some bony materials and lime stuck in there and so forth, and these different minerals, and then you get all the way down to the CaCO3, calcium carbonates. Right? Now, calcium carbonates are, even the lime and the limestone is called porphyritic limestone. It's not the limestone you find in the marine environments that is literally clear white limestone. It doesn't have all these inclusions in it, which are mineral inclusions, but limestone in the bodies of creatures is loaded with inclusions. They call it porphyritic limestone. It has all kinds of little fibers in it and all things of life. But the other type of limestone that's in the marine environments is the shells of marine creatures, which are limestone, calcium CO3, but it's almost clear. It doesn't have all of these extra things. And that's so that's the difference between the different limestones. So you go all the way from the flesh all the way up to the toughest part of your body, which is your tendons, and that's what I'm finding in space. And I'm finding them all over the earth, and I have tons of them here, tons and tons, literally in the tons. Okay, it's an article in Gizmodo, and it's complex organic molecules discovered on Rosetta's comet. Now, this was the Rosetta mission out to comet 67P, Germiaso or Churyenko, or I don't know what the name is, but it's some big long name like that. Now, these are the particles that they looked into, and they eventually, I followed it from the beginning, before they were even close to it. I knew what it was, and it is what I thought it was, and it is what I thought it was. Now, they looked at this, and they came up on it, and they saw all of a sudden, they said, well, they detected complex organic molecules in the dust surrounding this comet. So they said, oh, that's nice. And there wasn't all this icy, just gas and so forth. It was what you would consider a rocky little comet. So, complex organic molecules, mixtures of mostly carbon, hydrogen, oxygen, form the basis of our biology, have been hinted at on comets before. Well, they're not hinted at. They're saturated with it because they were alive. So they took two of the dust grains, and they looked into them, and the grains contain carbon-based molecules bound together, very large structures similar to organic matter found in carbonaceous meteorites here on Earth. Well, those are alive too. I've looked at every single one. I have one here that's got blood gushing out of it. Then they go into, our analysis reveals carbon in far more complex form than expected. It's so complex they can't even give it a proper name. Well, I can. That is the exact formula of life. This is what life is. Right there, you're looking at life. Hydrocarbons, iron, silicon, sodium, hydrogen, all of the same molecules that are in you. And they admit it, they know this, but they just can't deal with it. And they won't talk to me. I've contacted them many, many times, and nobody will contact me back. And I've sent them the information that I have. I mean, oh, this guy must be crazy. Well, I'm telling you what, I'm not the one that's crazy here. I have stuff that I can absolutely challenge me. I will show you that I have what you have and better samples, and it is what it is. So you can just hide from it, or you can deal with it. But you're going to have to deal with it eventually. I think this is what 67P is that's the bulbous end, and then it comes up like this, and it still has some meat stalks on there a little bit, and there was still a little flesh surrounding it, but not much. And this one's stripped very clean, but the other one would still have some of its other biology attached. All right, that is Comet 67P. Look carefully. This is the ball around the bottom, and that's the stalk coming up, and those little holes in there, I say, service it with blood. These are the flutes that anchor it in. And guess what I have? I have the identical same thing here. That's the stalk. All right, I hope you can see this. That's the stalk, and that is the ball. All right? This also was a meteorite. This came through space. All right? And it bled off. And all the volatile organic compounds were gone. And it must have come through at night when there's very little extrasolar radiation, and it must have hit at the correct plane that it just scalded and did not completely combust. And that is red blood from around that tendon ball, and that will have DNA inside. You could drill deep inside here, something that's not been touched, and find there will be chelation happens, which is where the metal complexes, which is also part of this metallation and part of carboxylation and part of these hydroxyl groups. The R that attaches, it has these metal compounds in them. All right, so they will chelate. In other words, they will get surrounded by molecules that protect them. It's sequestration. It holds them internal in a cage until you break that cage open. You crack those molecules with acid or something. And that opens them up, and the DNA comes right out, along with the metal complex, which is the hemoglobin and the DNA, and all that stuff is involved in the same place. Because it's a metal complex. It's a complex molecule attached to these hydroxyl groups and to other carbon chains. And the hydroxyl group goes out and breaks into these things to attach to them. That's what they do. It's loaded with ferrous oxides, as you saw, and hydrocarbons. That is the nature of life. Okay, this is Comet 67P. I have videos going back 3 or 4 years explaining this. That is a tendon enthesis, and this is the ball that sticks into, I believe this is a heel, and that is the stalk that comes up to where it meets the muscle. What is shooting out of here in all of these rays is the sun is boiling the blood vessels and shooting out these organic molecules. And yes, they are organic, as I showed you, or will show you, the chemistry of Comet 67P. It is not, it is understood. It's not something that's a mystery. This is fully understood. What the chemistry is here, what the anatomy is here, and that is life. And the space smells like steak. The astronauts go out on spacewalks. They come back in, they take their suits off, and they say, ooh, it smells like steak. Or they say also it smells like metals and so forth that are like not combusted. And that is exactly what it is, because your body is made of all of this specific chemistry. There's no mysterious at all, nothing mysterious. And they will find the identical same chemistry there, as they will also find here. These are the stone balls found all over the earth. They have this specific structure. And if you could see there, and I don't know if you can or not, but that's where the tendon strap had attached to this thing. Now, let's look at where else they're found in our solar system. Well, we know they're in stone balls like this all over the earth and clustered. I mean, everywhere, and these aren't even big. And this is the little bump that sticks off as the abrupt transition, and that's what we're seeing on Bennu. Sometimes they break off internally, sometimes they break off up here, or right about there, actually. All right, get your mud fossil eyes on. This round ball here is one of those tendon balls. That's the stalk that comes out. That's identical. I mean, it would be, except this got more eroded, but there was a ball with a stalk, the same thing that you see on Bennu. Well, that stalk would have come out and attached to these fibrous straps that hold it in place, the same as all of these tendon balls. Now, what happened with this is a meteorite. This came through our atmosphere and scalded all of the organics off and burnt it into a point where all that was left was this tendinous material, and it started to smelt. It started to smelt. Now, this is the red blood, and that will have DNA in it. I guarantee you there'll be DNA in there. That is the red ferrous oxide blood from the arterial passageway. This over here is the vein, and the vein comes to the black side, and it does not blow out. Vein blood hardens up. Red arterial blood explodes out of here. That exploded out of here, coming through the atmosphere and burnt up and exposed us. Some of them turn into iron. Now this must have hit at a certain type of angle that it just scalded it seriously and ripped everything away in these planes, but didn't destroy it. Some of them actually turn into iron, and you can still see the blood in them. I'll show you one. All right, this is an iron meteorite, came through our atmosphere and literally smelted. So my estimation of this is it was either a heart or a lung, which is the things that are saturated with the red blood of which is saturated with iron. That's the source of iron. So as it comes through the atmosphere, the heart or the lung smelts. It literally smelts like you had boiled off all of the organic material, and it turns into a puddle of stuff coming through the atmosphere, and all the organics gets ripped away, basically, to most degree, and the metals take on this effect where they all mix together. And when they cut it across, and then they add acids and so forth, they etch, and you can see the different colors of these metals. That means it's different metals. So what is this? That's the blood. That's the blood. That's the red blood for the artery. That's the black blood for the vein. This was, I believe, one of a lung or an artery or a heart. It's the only thing I can say. And the organics, everything vaporizes off in temperatures. The more, they call them volatile organic compounds. Organic compounds are stuff like in me and you. They say organic means carbon. Well, that's what it is. It's carbon-based stuff. Is all life. Well, everything was life. Now it's being revealed that's true. But organic compounds vaporize off in their temperature ranges. So the cheap ones, the little low temperature ones, they're gone. Oxygen, hydrogen, all that nitrogen, all these little lower end things. And then as you get up higher and higher, they harder and harder to vaporize off, and you end up with the heavy metals, and then by it's all done, you end up with carbon. Carbon is the last one to vaporize off at, I think it's around 7,000, 8,000 degrees. So that's what we got going here. They have to pay attention to what is really there, because I know it's hard. And you're not going to look like a fool. You're going to look like a fool for keeping hiding from this. Now, I showed you how these stone balls form. You see that mimus? That's a tendinenthesis. You see Iapetus, that's no question it's a tendinenthesis. You see that? I've got videos on all of these things. And they're all biological. There's the different biological implants. There's that seam like I showed you on those other tendon balls. It is what it is. All right, if you're really invested in mud fossils and you want to see the truth exposed and have our people that we respect look into the claims that I'm making, because they are factual, they are not without merit. I have DNA tests on my giant mud fossils. There is no question what I'm saying is at least worth looking into. So I never get any response from anyone. It's been 6, almost 7 years probably since I've been trying to contact people over and over and over. So what I'm going to need you to do, they had a Twitter thing where you could call, send these Twitter feeds and say, well, what about this, what about that, for an hour or so. Well, here's the people that we need to contact. These are the people what experts from Osiris Mission answer your questions. These are the people. And they have, you click on each person and it shows you how to contact them or who they are or something about them, where they work. Now, this is if you go on here, it's called www.asteroidmission.org/Osiris-Rex-2018 / and that will bring you to this Osiris Rex place. And please try to contact these people. Ask them, please look into mud fossils, because I'm going to try to contact them. But again, I've contacted almost everybody at NASA and Washington, D.C., all the universities, and now I'm pretty much shut off. I got to be honest with you. They will not respond to me whatsoever in any manner so far. I could be wrong. These people could be very receptive. This is what their job is. I was hoping, but so far nobody's fulfilled their requirements of their job. Now maybe these people are different. So if I'm going to contact them, you contact them, maybe we'll get somewhere, right? Mud Fossil University, and if I have shown something that you disagree with, I certainly like to know why. And I certainly like to help and work this to its conclusion. All right? Scrutinize it. Challenge me. I'm ready. I have what all these things are very, very simple to test and to look at. But I've done it. I've done chemistry. I've done everything. So it's time for somebody else to say, okay, let's look at what the guy's got, or I don't know what else to say. At this point, I'm at wit's end because nobody will pay attention to anything. So, that's all I have to say. God bless you. Thank you. Goodbye.